And now we continue to learn Chapter 2, Determinants. Section 3, Additional Topics and Applications. The first part, we will learn the adjoint of a matrix. Definition: let A be an n by n matrix. We define a new matrix called the adjoint of A by this way. So adjoint of A equals this matrix, n by n matrix. Each entry comes from a cofactor of the original matrix A. See, so the first column, see, is A11, A12 till A1n, comes from the cofactors from the first row of A. And the second column comes from the cofactors corresponding to the second row of A. And the last column, AN1, AN2 till ANN, capital A, comes from the nth row of A, the cofactors of those entries. Okay. By the fundamental lemma in this chapter, lemma 2.2.1, we know that AI1 times AJ1 plus AI2 times AJ2 plus T1 plus AIN times AJN equals the determinant of A if I equals J, or if I does not equal to J, this is 0. Okay, so immediately using this lemma, we can have A times adjoint of A equals determinant of A times identity matrix. So see this basic formulation for the adjoint of A, this property, we have A times adjoint of A equals a number times identity matrix. If this number determinant of A does not equal to 0, that means if A is non-singular, then we can divide both sides by determinant of A. We will get A times adjoint of A divided by determinant of A equals identity matrix. So this implies that A inverse equals 1 divided by this determinant of A times adjoint of A. So this is a formula for A inverse using determinant and adjoint of A. Okay, with this example, let A be a 3 by 3 matrix. Then adjoint of A, we can compute, for example, A11, A12, A13, cofactor A11, A12, A13. Here, for example, A11, capital A11 here, should be a sign. The sign is -1, 1 plus 1, so it's 1, times the determinant of the corresponding 2 by 2 submatrix here. The first row is 2, 2, the second row is 2, 3, and this is a 1, 1 entry here. And here, 1, 2 entry, we just using the cofactor corresponding to this entry of A. And then you can get the remaining submatrix. Deleting this row, the first row, and the second column is 3, 2, 1, 3. Here, because it's cofactor, we have a sign here. The sign is -1 power 1 plus 2 because it's first row and the second column. So we have this one. Similarly, we can have the cofactor of A13 here. And we write all the cofactors corresponding to each row, and we get this one. And then do the transpose. Be careful. Here we need to do the transpose to get adjoint of A. This means for the first column of adjoint A, it should come from the first row of A to get the cofactors there. Okay? And then we compute adjoint of A here, and we found it's a 3 by 3 matrix. Okay, and after we get this 3 by 3 matrix, we can have A inverse equals 1 divided by its determinant times adjoint of A. So you can compute about a determinant of A. Determinant of A can be computed by using also elimination way, right? Using Gaussian elimination, you try to transform A to triangular form. and you will get determinant of A easily, and then you will find A inverse equal this one.